In this video, we will split our tilemap collider into chunks, so multiple smaller colliders to improve the performance of our project from the current state where the FPS drops are pretty significant. In our project, we will need to create a new script, so let's right-click, create a new monobehavior script. Let's call it Chunk Manager. And let's open it up. First of all, we can delete the start and update methods, and instead we are going to create a list of tilemap collider generator, and we need to right-click and import the missing library using system collections.generic. Let's call it m_chunks equals new. So here is where we are going to store references to all the collider chunks that we have created. Now to do that, we will need to create public void add chunk method that will take, tilemap collider generator a chunk. And here we are going to just add m_chunks.add our chunk. Next, we will need to be able to retrieve the chunks to modify them. So let's create public list of tilemap collider generator. Well, let's call this method get closest chunks. And we are going to get a vector to world position. What we are trying to achieve is a way to update multiple colliders, so multiple chunks at once. If we click in this area where all of the 4 colliders meet, we are going to have to make a hole in all of those chunks. So this is what we want to calculate using our new method. Because I want to use a lists sort method, but I still need to create pairs of distance and the tilemap collider generator references, I'm going to create a list, open the triangular brackets and open parentheses, and we are going to create a tuple passing float distance tilemap collider generator chunk closest chunks equals new. To fill in this list, we are going to loop for each tilemap collider chunk in our chunks. So after we have added those chunks to our m_chunks list, we are going to create float distance equals vector 3.distance, and we will need to get the distance between the tilemap and this world position. Now, since we need to have a center point of our chunk, we are going to call chunk dot with the capital C center, and we do not have this property yet, but we are going to pass world position as the second parameter. And next we can call closest chunks dot add, and we are going to add the tuple. So again, we are going to use parentheses distance comma chunks. We need to have the center parameter, so let's go to our tilemap collider generator. I have the script opened here, and at the top we are going to create a prop, and I'm going to press tab to use a snippet. I'm going to type vector 3, press tab again, and I'm going to call this this center with capital C, and I'm just going to set the setter to be private. To set it, we're going to do this in the prepare collider method, and here we are going to, after this for loop, or 2 for loops, we are going to set vector 3 int center tile equals, and we can get this by getting the half of this length and half of the length of the first array. So the new, and this the first array is y, so the height, and we need to get the width, so we're going to get pixel with the index 0 dot length, and we are going to divide it by 2, which will give us an int value, so it is perfect for vector 3 int. And we are going to pass as the second parameter pixel state.length, so the length of the first array, and this will give us the height, half the height. So this will be the center tile, and now the center will be equal to m_tilemap dot cell to world, and we're going to convert the cell position, so center tile, to world position. Great, let's save the script, and we need to go back to our chunk manager to finish writing this method. So I have said that we need to have a list because now we can call closest chunks.sort, and we can use this method to sort those distances. We need to get 4 closest tiles. Obviously, we could get only fewer based on the radius of our explosion, but for our simple solution, we can use the sort method and pass in the parentheses a and b. So this will be a lambda expression. So a is the first distance and b is the second distance that we are comparing, and we are going to create the method that defines how we are going to compare those. So here we are going to type a, so this distance first, dot distance, because we have a tuple, so we need to access either the distance or the chunk. So if the a distance dot compare to b dot distance, and this compare to method will compare both, and it will define if the value is equal, greater, or less, and it will output an integer value. So the output will be that the closest chunks list will have the smallest distance values at the start, and those will be tuples. So now we can just create a list of tilemap collider generator, closest chunks to remove equals new, and we can type int count, because we can have only one chunk defining our texture as well as multiple. So let's define math f.min. So we need to get a minimum of 4 chunks if we have multiple chunks, but we can also get less depending on how many chunks we have in our grid of colliders. So this will take care of this problem. And if we have this count, we can loop for I equals 0, I less than count, I plus plus. And here we are going to add to our closest chunks to remove dot add. And we are going to add the closest chunk with the index I, and we are going to call dot chunk. So this is how we are going to extract the chunk from our tuple and add it to this list, and now we can just return this list, and here is our method finished. To visualize our chunks, we can just add one more method, public void draw gizmos, and we are going to get a vector 3 chunk size and a vector 3 half size. And here we can check if m_chunks dot count. So if we have any chunks is greater than 0, we are going to loop for each tilemap collider in m_chunks. We are going to call gizmos dot draw wire, and this is wire cube, passing the this is chunk dot transform dot position plus half size, because this method requires the center of our cube. And next we are going to pass the chunk size to draw the cube, and we do not need those parentheses. And just to show where is the start point of our tilemap, we are going to call gizmos.draw sphere, and we are going to pass the chunk dot transform dot position, and we are going to pass the radius 0.1 f. So this will draw a sphere at the position where the tilemap starts, so at 0, 0 of the tilemap. Now this script is done, so let's save it. But to use it, we need to go back to our terrain, destructible terrain class, and I have it opened here. So at the top, we need to add the reference to our serialize field. This will be private chunk manager m_chunk manager. Now to create our chunks, we need to also define a serialize field private vector to int. This will be m_chunk size, and let's define it as new 300 by 300. This is value in tiles or in pixels, or this will be their maximum size. Now that we have that, we need to go to our start method, and we had this code that calculated the bottom left local position. We can leave this code, but the rest we need to comment, so we can press Ctrl-K, Ctrl-C to comment this code. Now we need to split our texture into collider chunks. To do that, let's create vector to int chunk grid size equals, and let's define a new method, split texture into chunks. And we are going to have to pass here the size of the texture, so m_modifiable texture dot texture with capital T dot width. The next parameter will be the m_width modifiable texture height. And lastly, we need to pass the size of our texture, so m chunk size, of the chunk, m underscore chunk size, which is the size of the chunk, that maximum size of the chunk. Okay, we need to create this method, so right click, show context, and I can create this method. And let's implement it here. I'm going to just rename those parameters to width and to height. And here, instead of throwing an exception, we are going to calculate int chunk count right. So this is how many chunks to the right we are going to have, is equal to mathf.ceil_to_int, and we are going to get the width value divided by the chunk size x, and we're going to calculate the same up. So int chunk count up, because we place our chunks from the bottom left corner up and to the right, mathf.ceil float height divided by m chunk size y. And next we can return new, and let's pass the chunk size right, or count right, and chunk count up. Let's go up to the start method, because that's not it. We also need to get the values of our pixels, so bool, and let's create an array of arrays. Those will be pixels, equals m underscore texture, modifiable texture, dot we should have a get pixels state method, because we again need to get this to fill in our tile maps. With this done, we need to prepare our chunks, so place them based on our grid size. So let's create prepare collider chunks method, and here we are going to pass the chunk grid size as a first parameter. Next, let's pass the m underscore chunk size, I think we had, so we will need that. Next, we are going to get the bottom left position of our texture, which we had calculated previously, so bottom left local. And last parameter will be the pixels, so the values of our pixels, so that we can place those tiles accordingly. Again, let's right click here, show context, and generate this method. Let me try to move those parameters to a new line. And actually before that, I think we have an error here, because we are getting the pivot in the normalized space, but we actually want to get, let's comment this size out, and we want to get a negative of modifiable texture dot sprite dot pivot in pixel space. So this will be bottom left pixel. And only this way our calculations later will be correct. We will start by creating two for loops. So for, and this will be int x equals 0, and this will be x less than chunk size dot x plus plus, and we will need to have another loop for, and this will be y equals 0, y less than m chunk size dot y plus plus. I have made an error here because we do not want to loop for each chunk size, but the chunk grid size, which is the number of chunks on x and number of chunks on y. We did this because we start with the bottom left corner of our texture and we place our first chunk, and then we go to the right and we go up. So that's why we have a loop on x and on y value starting from 0 going up and to the right. By the way, I know we have interchangeably used the size of the texture and size of the sprite, so I just want to point out that our code assumes that the sprite mode is single and that the sprite and the texture has the same size. If you have a texture that contains multiple maps, you might need to modify your code to get the size of the sprite rather than the texture. Okay, with that out of the way, we need to calculate the offset, so vector3 int offset equals new vector3 int, and this will be x multiplied by m chunk size dot x, and y will be multiplied by m chunk size dot y, because we place our chunks every 300, I think that was the size, on x and on y. This is the max size of each tile map. But this is in the world space. But we are talking about tiles and not the world space, because the grid has a specific cell size set. So we first need to calculate vector 3 bottom left corner. So this will be the bottom left corner of our tile map of our chunk is equal to a vector 3 in the parentheses bottom left local, so this is from our parameter, plus the offset. So we are still talking about the texture space or tile map space. So to convert it to the world space, we need to calculate bottom left corner dot scale, and we need to scale it by m_grid dot cell size. Well, actually, it is in the local space, not in the world space yet, if the grid is not a child object of our texture. So for safety, we can say that the bottom left corner is equal to m_sprite_renderer dot transform point, and we are going to transform the bottom left corner so that we convert it from the grid local space to the world space based on the position and rotation of the m_sprite_renderer. This shouldn't matter in our case, but in case of other setup in the scene view, it might be important. So we know where to place our chunk, so let's create tile map collider generator. The collider generator equals, and we are going to instantiate, so maybe on a new line, instantiate, and this was the m_collider generator. This was our prefab. We are going to spawn it at the bottom left corner with quaternion identity, and we can spawn it as a child of m_grid.transform. Okay, so let me maybe move some of those parameters to the new line. To make it easier to recognize those chunks, let's call our collider generator .gameObject.name, and let's set the name to be with the $sign. Open the quotation marks. Let's type chunk _x and _y. And now this will change the name of the object in the hierarchy. And we are going to call m_chunk manager.addChunk, and we are going to add the collider generator. But now we have the bool array of arrays of pixels that define the whole texture. But we only need part of it to fill in the tile map of our chunk that represents our chunk, so the part of the collider. So we need to create another bool array of arrays, chunk pixels equals, and we are going to not pass the pixels, but we are going to create a new method called slice array pixels, the offset x, offset y. But that's not all. We need to pass mchunk size x and mchunk size y. So those parameters will all be needed to separate the pixel values that we need to pass to our chunk. I believe there is an error in my prepare collider chunks. When I was passing the parameters to the sliced array method, I should have passed y as the first start row and x as the start call. And the same in the num rows will be y parameter and num calls would be x parameter. We can right click on this method and generate it, but for now let's finish writing this method. So we are going to call collider generator dot prepare collider, and we are going to pass our chunk pixels, and this will be it for this method. We need to just finish writing this slice array method. Okay, let's try filling in this method. So we're going to create int source width equals our pixels dot length, and we are going to call int source height equals pixels with index 0 dot length. Now we need to get the actual length of the array that we are going to create. So int actual width equals math f dot min. Let's maybe rename those parameters. The offset x is the start row, and the offset y is the start column. So start col, but the next two parameters are the number, so num rows and num cols. So we get the start row and start column and the number of rows and the number of cols that we want to get. So this way we can get the actual width equals the min value between num rows and the source width minus the start row, because maybe there is less rows left of pixels, so the tile map will be smaller. And in actual height will be the same with the num calls and source height minus start calls. Now we have the actual width and height that we need to take. Now those two calculations could produce negative values, so let's make sure that the actual width is math max, and we are going to get 0 and the actual width, so we get at minimum 0 value, because next we are going to create our array. So bool array of arrays result equals bool or new bool. We are going to get the actual width, and the second parameter we can't really set yet. And next we are going to look for int equals, and this will not be I, this will be row. And we are going to loop up to actual width. And next we need to do the same with the columns, but first let's set the result with the index row equals new bool with the actual height, because we are creating an array of arrays. And now we can loop for, this will be call equals 0, call less than actual height, call plus plus. And now we have that we can set. Now we can set result with the index row and call equals the pixels with the index start row plus row and the start call plus call. And with this we can return the results array of arrays. And with this method finished, we need to go down to the remove terrain add method, because previously we had called this m_non-chunked collider. We are going to comment out this line. We will create a list of tile map collider generator, and this will be called chunks to modify equals, and we are going to call m_chunk manager dot get closest chunks, and I think we had to pass here the world position. When we have this, we are going to just loop for each var, and this will be our chunk in, this will be our chunks to modify, and we are going to call the chunk destroy collider, and we are going to pass the world position affected pixels as offset, and this is how we are going to affect every chunk that is close to the position where we have clicked. To show gizmos of our chunks, let's just create private void on draw gizmos, and we can add on draw gizmos selected. This is Unity method, and it will allow us to draw gizmos. We are going to type if application is playing. Only then we want to check if m_chunk manager is not null. If it is not, we are going to calculate a vector3 chunk size equals new, and we are going to set it to m_. Let's type here vector3 chunk size equals new, and in between the parentheses we are going to type m_chunk size dot x multiplied by the m_grid dot cell size dot x, and as the second parameter we are going to use y and y of the cell size, and we can pass 0 as the third parameter, but it will be passed by default. Vector 3 half size equals the chunk size divided by 2, and we are going to pass f so that we get float values. And lastly, we are going to call m_chunk manager dot draw gizmos, and we need to pass the chunk size and the half size, and we pass those so that we can calculate them once and then pass them instead of calculating the half size in the chunk manager, although it wouldn't matter really. Okay, we are done writing the code. Let's save it. Let's go back to Unity. Here, let's select the terrain generator, and we have the destructible terrain, destructible test, and we are going to now drag the chunk manager here. And we need to assign it to the destructible terrain script. And I believe that is it. So let's press play. If everything went well, if you turn on this shading mode, you should see our grid showing. And this is the gizmo. If we select our terrain generator, we should see the gizmo. If we select anything else, and I think we want to see the colliders, we can select those, and those will be showing. And the terrain will be showing as well. So we have our collider for the terrain. And if we select our stats, and let's see if we can still destroy it. And in the preview, you should see that all the different chunks receive the data where to create the holes. So everything works much more smoothly, and we still have a way to create holes in our terrain, and the collider corresponds to how we have created those holes in the terrain. Okay, great. So this now works. The performance is decent. So now we can expand this terrain system on your own, polish it a bit in terms of the performance, but overall it should be usable for different types of games. Thanks a lot for watching, and thank you to all my Patreons who are supporting the channel. You're awesome.